So a lot of times when you're asked a word problem question, they probably be asking you for special vocabulary words. Like they won't be find the x-intercept or find the zeros or find the y-intercept. They won't do that. Okay? They will be asking you, what is your initial profit? What is your break-even point? When did the ball hit the ground? These are the questions that they're going to be asking you. Now, you need to understand what these vocabulary means, right? Or what is your optimal profit? Or things like this. So let's look at this. When you are solving a word problem, sketch a situation. You see me like always sketching. Even if it's wrong, I can erase later and then sketch it properly with the proper points, but at least for me to visualize. So if there is a rock falling, I go like falling. I kind of, not like this, like this, right? A rock's falling. So I'm standing right here and I'm throwing a rock and then it's going up and then going down, okay? If I'm throwing a rock, I'm going to throw it like this. It's going to go up and then go down. So this way, when they ask me the question, I kind of pinpoint what I am looking at. Consider how key features relate to the context of the problem. So when I'm asking you, what is your initial point? What does that mean?
That means the starting point of
the starting point, which is where? The y-intercept. It's the y-intercept. Where was the rock when I first threw it, right? So that's your y-intercept. So anytime you're looking for an initial point, you're looking for your y-intercept. What is your break-even point? So if you're selling your chocolate bars, what's your break-even money? How much money would that be?
It's when you make what you spent on them.
Which is how much? How much in total? Like how much money? How much profit did you make? How much profit did you make? Zero profit, right? If you made money exactly the same thing as much as you spent, that means you made zero for your own pocket, right? $0. So always your break even is when you're looking for your zeros. You're looking for your x-intercepts. So my break even point is when I'm looking for the zeros. Okay? Another question that you probably see often is, when did the ball hit the ground? Okay? Or when level. Okay? And then you're looking at when did the rock hit the ground, so I'm looking for this point, which we call the zeros. Remember the first thing we went over is naming these key features. Remember that? We named this the vertex. We named we named them the x-intercept or the zeros. Do you guys remember this sheet? Maybe the second lesson, right? After the review. We called this the y-intercept, right? And there's a reason why we went over this vocabulary, because we need to use it. Maximum, minimum profit, or minimum distance, or minimum height, or maximum height. What does that look for? What are you looking for here? What part of the vertex? The y value, the optimal value. So you're looking at the y value of the vertex, right? And if they're asking you for the point at which the maximum or minimum occur, so because it's a point, that means I'm looking at the whole vertex. So let's look at another example here. Let me just enter this picture. Give me the vertex form. And I'm going to ask you this for the last time. What can I find from the vertex form? The vertex. Okay. Which is my maximum point, right? Good. Now, give me the standard form. I can't hear you. What can I find from the standard form? The y-intercept, which is what? So I can find, you know what, let me just erase this for a second. So this is, right here, is the y-intercept. Give me the factored form. So, where are my zeros? Right? What can I find, sorry, from the factored form? The zeros. And which are the x-intercepts as well, right? So I can find these. Okay? Good. So when the question is asking you for something, first of all, you have to figure out what is it asking you for, and then you have to put it in the correct format to put it in. So let's look at the question. A path of a soccer ball can be modeled by the relation h equal to, I'll get back to it, h equal to negative 0.1 d squared plus 0.5 d plus 0.6, where h is the ball's height and d is the horizontal distance from the kicker, both measured in meters. Find the zeros of the relation. So here's a question that you're going to get, for example, you have on a quiz, on a test, what would you do? So it's in standard form? Yeah? This is in standard form? Okay, and I have to convert it to factored form. Why factored form? Good. So I can get the zeros in factored form. How do I convert this from standard to factored? Factoring what? So do a common factor first, right? Remember, when you're factoring, you're asking yourself, do I have a common factor? Do you have a common factor? When you have a situation like this, try your A value. Okay, you want to factor that A value out. So if I divide by negative 0.1, do I get whole numbers? Yes. So H equal to, I factor out a negative 0.1. What do I have left? What do I get for the first term? D squared. What do I get for the second term? If I divide 0.5 by negative 0.1, I'm going to get a negative 5. You can try it on the calculator and confirm. If I divide 0.6 by negative 0.1, what do you get? Negative 6. So my leftovers looks nice and neat, right? So I'm looking for two numbers that multiply to what and add to what? Guys, if you're not using your signs, multiply to what? Negative 6. What does it add to? Good. So, green sheet, both my B and my C are negative. So I'm looking at the large number to be negative and the small number to be positive. What multiplies to 6? So the large has to be negative. So 1 and negative 6. That's it. What's 1 minus 6? So I already found my answer, right? So H equal negative 0.1, D plus 1, D minus 6. Is it in factored form now? Okay, what are my zeros? So take each bracket, set it equal to 0. So what goes on the y-axis? What's on the y-axis? What does the y represent in this? What letter? So you have two letters, either H or D. Which one is y? H. Because this is y equals ax squared plus bx plus c, right? So instead of y, I have h. So the height of the ball is on the y. What's on the x? The distance from the kicker. Okay, so the height of the ball is on the y. The distance from the player is on the x. So negative 1 is right here. So this is where the player is standing. The player is standing in the middle, right, on the origin. And the ball is right here. So the ball hit the ground at 6 meters away from him. And then -1 meter. So where would the -1 meter be? So if he's standing right here, right, and he's kicking the ball. So the ball hit the ground 6 meters away from him, and -1 meter. So where would that be? Behind him. Behind him. That's where the -1 be. Right? Can the ball be behind the player if the player is kicking it? No. So do I need to represent this? Sometimes we have to omit information that doesn't make sense. Okay? We care about when the player kicked the ball. If the ball was behind the player, we don't care about that. So we omit that. Because distance, sometimes negative distance doesn't make sense. Sometimes it does, depending on the scenario that you're looking at. But in this case, the ball was behind him. That's what -1 means.
In this scenario, would it be maybe he was holding the ball?
Yes,
and kicked it?
that's right. So the ball was higher, not on the ground when he kicked it. Okay? So the ball was on the ground, -1 meter behind him, but we don't care about this scenario because we care about when he kicked the ball. It's going to go up. It's going to go back down 6 meters away from him. So in this case, we're going to omit this. Okay? And we're going to say that the ball hit the ground 6 meters from the player. So what does the zeros represent or mean in this context of this question is when hit the ground, which is 6 meters away from that player. Are we okay with that? All right. So each scenario, you have to take it, each scenario by scenario. It depends on the question. It depends on the kind of question that you are being asked. You always have to ask yourself, because they're not going to, sometimes they're going to use Y and X, but sometimes they're going to use different letters. Make sure that you know which one goes on the Y-axis, which one goes on the X-axis. Can we look at this example right now? So the arc of a small suspension bridge over a river can be modeled by the equation y equal -2x squared plus 4x plus 6, where x is the distance in meter from the edge of the river, and y is the height above the ground, also in meter. So we know that x is the distance in meter from the edge of the river, and y is the height above the ground. So basically what I have a scenario here where I have this, right? And this is the edge of the river. So let's say this is the river going in the middle. This is the edge of the, so this is the distance from the edge of the river, okay? That's a very steep bridge. Let's make it less steep. So not symmetrical. Anyway, what are the zeros and what do they represent? What are the zeros? How do you find them? Into what form? Factored. So convert into, I can't understand you guys. It is in standard form. Convert to factored form. So take the greatest common factor out. And it's -2 because your A value is -2. So I'm going to divide by -2. And that gives me x squared minus 2x minus 3. Then I'm looking at sum and product. So I'm looking for two numbers that multiply to -3 and add to -2. What multiplies to -3? I don't have too many options. Since both of them are negative, then my large number is going to be negative and my small is going to be positive. And they add to -2. So in this case, my two zeros are x equals 3 and x equals -1. So if I'm looking at this, this is my where this is the river right here. So basically my y-axis is my river. So the edges, basically what are the zeros and what they represent. So I'm looking at this. This is at 3 and this is at -1. Can I omit the -1 in this case?
No,
Why not?
because it accounts for the bridge, the ends of the bridge, and if the y-axis is the river, you still have to account for it.
That's right. In this case, if I don't account for this part of the river, of the bridge, then I'm having a bridge that's suspended in the air. It starts in the air, and then when you get to that point, then that's it. You have nowhere to go. I don't think that's a good idea, does it? Is it? Right? So in this case, I have to count the negative. And you see, I told you, it depends on the scenario. Some scenarios you don't count the negative, but some scenario you have to count them. In this case, you have to think about it. This is your river, and you have a bridge that's going from one side of the river to the other side of the river. So you have to count both sides. Right? So if this is your river in the middle, you have part of the bridge on the left side, part of the bridge on the right side. Okay? So what do they represent? They represent when the bridge touch the ground, no? That's where the zeros are, is when the bridge is on the ground, right? It's not in the air anymore. Horizontally, how long is the bridge? How wide is the bridge? 4 meters, right? -1 to 3, right? It's running horizontally for 4 meters. So if I'm looking at how horizontally, how wide it is, it's 4 meters. You have -1 from the left and then 3 from the other side. So it's 4 meter long.